All right, so here we're going to get started on some that are just a little messier. When you're working some of these problems that are a little messier, it's not always clear what's going to make it feel the simplest. And, you know, sometimes there's just two really good ways to do something. All right, on this one, both the x and the y are underneath that radical. So that's like an xy all raised to the 1/2 power. Now you could separate that into x to the 1/2 and y to the 1/2, but I thought I'd see what would happen if I just tried to do the derivative from there. Okay? And like I said, sometimes I don't know if it's the best way until after I've gotten through it, and then I realize, well, you know what, maybe it would have been better the other way. So let's try it like this. So we're taking the derivative with respect to x. So we've got a power function over there. We're going to bring the 1/2 down, keep the xy. It'll now be raised to the negative 1/2 power, but I'm going to have to multiply by the derivative of the inside function, which is a product. So it's going to be kind of long. The derivative of x would be 1 times y as is, plus x times the derivative of y would be y prime. Okay, so that's the derivative, all of that is the derivative of just the left-hand side. Now I'm going to come over and do the derivative of x squared, which is 2x times y as is, plus x squared times y prime, and the derivative of 1 would be 0. Now I've got a y prime in a couple spots, here and here. So I'm going to work towards getting those two terms to where I can have them on one side and everything else on the other. Okay. So, I don't know, there's several ways I could do it. I'm going to go ahead, I think, and distribute all of this. Remember, 1 times y is really just y. So I have a 1/2 y times the xy to the negative 1/2 when that goes to there. And then I'm going to have a 1/2 with an x and an xy to the negative 1/2. Still times a y prime when it gets distributed to the second term. And the order you put those in really doesn't matter. I usually put my x's first and then everything else, and I like my y primes to be at the end. All right, and then I'm just going to bring down the rest of this. And then these x primes that I see, I'm going to get onto the same side, so I'm going to take, oops, I don't want it in green. Get rid of that. Let me do it back to blue. So I have a 1/2 x, xy to the negative 1/2 times y prime. I'm going to subtract the x squared y prime that you saw on that right-hand side. Then I'm going to move, to keep the 2xy on the right, and then move this first term over by subtracting it. Trying to make sure I keep everything grouped in parentheses like I need to. Now these y primes can be the y prime can now be factored out. And when I factor it out, what's left is a 1/2 x times xy to the negative 1/2 from the first term, and then an x squared from the second term. Okay? And all of that is equaling what's already on that right-hand side. All right, and I want this y prime by itself. So I'm going to divide by the 1/2 x. I'm going to divide by, I don't think I need to write that, what you see right here on both sides. So I'm going to have my y prime equaling 2xy minus 1/2 y, xy to the negative 1/2, all divided by 1/2 x, xy to the negative 1/2 minus x squared. Now, mistakes people make a lot of times are thinking you can just go in and knock out these x squareds, xy to the negative 1/2, I mean, things like that. You can't do that. There's a minus here and a minus there. So that's not going to be okay, right? So you can't do that. You have to get things to be factors of the numerator and the denominator before you can do that type of thing. But you also can't leave your answer looking that bad. So you're going to have to do something. So this one's just kind of messy. And it's not real obvious, like our normal factoring out step. Seems a little awkward here. So I think I would probably, let's see. I don't know. I'm trying to decide which way might make the most sense to you. Okay. Probably the thing that might make you see it the best on this one. I think what I'll do to try to explain it here is rewrite without these negative exponents. So you really have a 2xy minus a y on top and then a 2 with an xy to the 1/2 on the bottom. I would keep it in exponents for a little bit longer until we clean everything up. Then here I have an x on top with a 2 and an xy to the 1/2. But I'm keeping it all below that large fraction bar, minus the x squared. Right now, I really have little fractions inside bigger ones, and this winds up being the denominator of both of those. So I'm going to take and multiply by that on both the numerator and the denominator, and then when I distribute, it's going to knock out those little denominators. Okay? So top left is going to have a 2xy with another xy, another 2xy, another 2xy all raised to the 1/2 power, and then just minus y. So it knocked out that little denominator. And then down here, when I distribute that 2 times xy, this right here, to the 1/2 power, I get just x in that first spot minus x squared times 2xy, I'll just put a times sign, to the 1/2 power. Okay, make sure I didn't lose anything. Nope. Okay. All right, I'm going to move my question number 5 down a little bit. All right, so let's see where we're at this point. Okay, so if you're trying to clean that up at that point, gosh, there's all sorts of things you could do. Well, I'm contemplating how to make it look the best. So this right here is really to the first power. I could put it with that xy to the 1/2 power, but I noticed in the denominator that's not the case. So I was thinking I might just leave it with a 4xy and then a square root of xy minus the y. And in the denominator, leave the x minus, and then just get that 2x squared written more naturally with the number out in front with a square root of xy. Maybe something like that. And that looks pretty good. That would be a good stopping point. So this one, depending upon how you approached it, you might have answers that look a little different than what I wound up with at the end. For instance, this first part right here, okay, you might have thought of it as 4 times the square root of xy cubed, because that's like xy to the first and xy to the 1/2, so that would be 3/2. So little things like that are what can be kind of frustrating, but you need to try to understand what's a big idea and what's a little idea. That wouldn't matter that much, how you wrote it, okay? All right, so I'm going to let that one go. Let's take a look at number 5. 5 is kind of a fun one. I'm going to move it to a whole brand new page. Okay, we can't get the y by itself even if we wanted to. So that's why it's in this section, using implicit differentiation. So any term that has a y in it, it's going to wind up having some y primes. But things like x squared, that's just going to be 2x when I do the derivative. So I'm going to go ahead and start doing the derivative. All right, now when I do the derivative of e to the power, it's e to the power, but I have to take the derivative of the inside function, which is that xy. And it's a product. So I'm going to do a bracket there because it's going to be kind of big. So the derivative of x is 1 times y as is plus x times the derivative of y with respect to x, which would be y prime. All of that is the derivative of that first term. Then the derivative of x squared would be 2x. The derivative of y squared would be 2y times y prime, and the derivative of 10 would be 0. Okay? So I was thinking on this, probably would do a little cleaning up on it by distributing that e to the xy to both. So that's y e to the xy plus x e to the xy y prime plus 2x minus 2y y prime. I like my y primes to be sitting at the end. I like to look for those because those I'm going to keep on one side, and then I'm going to move everything else over to the other side. So we're going to leave those where they are, the x e to the xy y prime minus the 2y y prime, and I'm going to subtract the y, that's an equal sign right there, the y e to the xy, and I'm going to subtract the 2x to move them to the right. So then those y primes are going to get factored out. And when I do, I'll have an x e to the xy minus 2y left. Okay. So we're going to work on getting that y by itself. All we got to do is divide by the x e to the x minus 2y. I said it wrong. The x e to the xy minus 2y. So I'm going to divide both sides by that over x e to the xy minus 2y. All right, now the only thing that you might see, the hard part is sometimes you do a really good job, but what you're looking at isn't quite what you see in the back of the book, so you think you did everything wrong. On this one, see the two negatives on top? They might factor out a negative from there, which would be ye, a negative 1 is what they're factoring out, plus 2x. And then they might do the same thing down here. So they'd have a negative x e to the xy plus 2y. And so then they can cancel those out. That would just be equal to a positive now. And so you might see the answer in the back of the book turning out to be equal to y e to the xy plus 2x, and those could be in either order, over a 2y minus x e to the xy. Kind of like that 2y first, so I don't have a negative hanging out in front. But again, you can have things in slightly different orders and still be correct. Okay. All right, I think I got time to do number 6, and then I'll do a new video for the last two. All right, so here we're trying to do implicit differentiation again. All right, so for this one, it's going to be a product rule problem. So think about where the multiplication is. That helps a lot. So I'm treating the 4 sine x as my u and the cosine y as my v. So the derivative of 4 sine x is just 4 cosine x. Okay, and it's a product rule. So now I'm going to add, oops, I didn't do the right thing though. So the derivative of u would be 4 cosine x. I need to multiply by the second function as is, and then I need to add to that the first function as is times the derivative of the second one. Now, when you do the derivative of cosine of y, that's going to be negative sine y times y prime, because y is the inside function, so you need to do the derivative of it. Then the derivative of 1 would be 0. So on this one, we just have a y prime here. So I'm just going to organize this a little better. So this would be negative 4 sine x sine y, y prime. Okay, and I'm going to go ahead at the same time and move that other term over. So I'm going to subtract it, so that's why it's negative now. And then to get that y prime by itself, since it's times in between, I can divide, and I'll wind up with my y prime equaling -4 cosine x cosine y, all divided by -4 sine x sine y. Okay. Now the 4, -4 over -4 would equal 1, so I can cancel that out. But the other part you could leave like that. I would take that completely. Okay, but again, you might see something different in the back and then think, what in the world, where did they get that? So I'll show you. Or they might have split it up, and cosine over sine would be cotangent. Cosine x over sine x would be cotangent x. And then cosine y over sine y would be cotangent y. So you might see them use some trig identities occasionally. I try to minimize the trig identities just to help you out a little bit. The only one I demand that you know or that you use is if you ever see cosine squared x plus sine squared x, you would need to replace it with a 1.